All right, we're getting into trigonometry now with section 8, or chapter 8, section 3. You're going to notice up above, what you see here, sine is opposite over hypotenuse. This stuff is up here, up on top. What we're going to learn is what is the opposite and what is the adjacent. We always can figure out what the hypotenuse is because the hypotenuse is always opposite the 90-degree angle. But what is going to be our opposite and adjacent sides? That's what we need to be able to figure out to get this right. Just calling one side opposite and one side adjacent doesn't work. You have to take a look at where the angle is. In this case here, this would be the angle that we're looking at. And if we look at that angle, the side opposite of it, it's called your opposite. The side that is not the hypotenuse but adjacent to it is your adjacent side. You always have to know where that angle is you're working from. If the angle switches and you're looking at this angle up here, then these would change. This would be your opposite side and this would be your adjacent. So in trig, when you start working with trigonometric functions, you have to know what angle you're looking at. That's ultra important. You'll never get it right if you don't know that. So that's the first thing we do. Next, we remember this. SOHCAHTOA. SOHCAHTOA, sine, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Notice opposite, hypotenuse, adjacent, hypotenuse. Tangent is opposite over adjacent. If you can remember SOHCAHTOA, you'll always have those sides right. Once we know what angle we're talking about, we can figure out what our opposite and adjacent are, and we should always know what the hypotenuse is. We're going to start with those three functions, but you are going to learn about three other functions, and that's the cotangent, the secant, and the cosecant. And what those are, I'll tell you real quick. Cotangent is the tangent inverted, where tangent is opposite over adjacent. Cotangent is adjacent over opposite. Secant is the opposite of cosine, inverted. Cosecant is the opposite of sine, it's just inverted. Okay, and we'll work with those later on, but we're not going to worry about those, just so you know what they are. These are the three that we're going to work on. These are the three that you're typically always going to use. We won't use the other three, I think, for the most part in this trig stuff. We'll stick with sine, cosine, and tangent. All right. Let's take a look at an example here. Given a triangle, we're given the degrees right here. Okay? We know from where the degrees are, we should know where our opposite side is. That's the side opposite, so we can even label this opposite. We know that this number up here, this is opposite my 90 degrees, so this is my hypotenuse, or my longest side. The hypotenuse on a right triangle is always your longest side. So we know that we're working with an opposite and hypotenuse. Which function works with opposite and hypotenuse? Everybody agree with that? Look up here. Opposite, hypotenuse, sine. So I see opposite and hypotenuse. I know that's what I'm going to use. And my theta, notice they have sine of theta here. Theta is always the degrees we're talking about. Theta is going to be degrees. So they're talking sine of theta equals opposite over hypotenuse. And now we can just start filling in. Sine of 29 degrees equals my opposite, which is x, over my hypotenuse, which is 13. And we can start to solve it. Does that look hard? Okay, calculators, use your phones if you want. Pop them out. Now the difference is on your phones, you got to be working in degrees and not radians. So if you come up with a different answer than what I'm coming up with, you're probably using radians, but we're going to work in degrees. So take a look on your phone, or if you need a calculator, and find sine. Do you see it? Got it? Push sine, and then put in 29 and hit equals. You should come up with 0.4848. Sine of 29 degrees. Maybe you have to push. Yeah, you can use a calculator. You're probably in radians then. Grab a calculator if you're coming up. If you don't come up with 0.4848. That's what you should come up with. You should do the sine. What we're going to do is we're going to figure out what this is right here. Sine of 29 degrees. Grab a calculator. Yep. Okay, on phones then, type in a number and then hit sine. Okay. If you have a calculator, if you look down at like one of these here, if you look down on the bottom right, it should say DEG. That means it's in degrees. If you're doing it on the phone. Yeah, see, I'm in radians. I'm in radians on my phone, and it comes up with a negative 0.6636. You shouldn't have that. .4848. Yep. All we really need out of this is going to be to 0.4848 is going to equal x over 13. Now we do a cross multiply. All right? Multiply 13 times that. And we should come up with 6.3 something. X equals 6.3 is fine. That means my side right here, this opposite side, is 6.3. Where would we use this? Sure we would. If you had an angle, you're working in, let's say, wood shop, and I will guarantee you that it's being used in wood shop. You'll have an angle, you'll have one side, and you want to figure out what your other side should be. You can use sine of this to figure it out. All right. This is used when, let's say, you're doing fab work with metal. All right. They need to know how long of a piece, or general idea of how long of a piece they need. And they know that. They know that they have to have, let's say this has to be 11 and a half feet, okay? And we know this angle here has got to be 30 degrees. And they have to come up with this side over here. Now, they're going out and they're looking for a piece of metal. Can they tell off 11.5 feet, what that's going to be, and this could be even longer. Let's say 30 feet. All right. Can they tell what it is? No. What if they use a sine? What if they did what we just did right now? It said sine of 30 degrees equals x over 11.5. How long of a piece would that at least have to be? Well, we come over here, we say sine 30 equal, or sine 30 equals sine of 30 equals, I got 0.5, half. And then we say we're going to multiply that by 11.5. 5.75, yeah, you're right. You did the whole thing. All right. So basically, there's at 5.75, so let's go get a piece of metal that's 6 foot long. And we can make it work in that. That's what we're looking for, a piece of metal that's 6 feet long. Quickly, we can figure that out. So yeah, this stuff can be used, guys, in what we're doing every day. Now that's more in the building side of things, but that's what it is. Looking at this one here, number 1, we've got 44 degrees right here. What side? We know this is the hypotenuse, right? It's a long side, so 22 is my hypotenuse. What's this side? Adjacent. It's adjacent to the angle. What uses adjacent and hypotenuse? Cosine. So now we know we can do the cosine of 44 degrees equals t over 22. And we can figure it out the same way. You see how we got that, Trip? Everybody see that? Case? See that? Okay. Damien, see what we're doing? Cade? All right. All right. So we see how we can find these out real quick using trig functions. Down on the bottom, here's what they're telling me. I need missing length, so I need this one and I need this one. I've got 20 degrees right here. My x is going to be my opposite. My y is going to be my adjacent, and here's my hypotenuse. We're using sine and cosine on these. Here's 60 degrees. I want to find my what? Hypotenuse. I'm going to call it z. And I want to find my what? Opposite. Opposite. Here's my adjacent. This is opposite. Okay? All right. Jump over to the next side. All right. Now we're going to get into, we can figure out how we can get sides real quick, right? How do we get angles? We know we're working with a right angle, but I don't know what angle I'm working with. I can find what angle I'm working with. So, in this case right here, I'm going to just draw something here. I'm going to give a side of 10 and give another side of 5, okay? And I want to know what this angle is right here, theta. We've worked on how to find sides when we have theta. But how do we find theta? Well, first we have to know what function we're working with. We've got a hypotenuse and we have an adjacent, right? Hypotenuse and adjacent. Which trig function works with opposite and opposite and hypotenuse? I mean adjacent and hypotenuse. Cosine. Cosine. So we know cosine. So we would write it out. Cosine of theta, because we don't know what the angle is, equals 5 over 10. That's theta. This is theta. This is a Greek symbol called theta. It's a Greek symbol. There's beta, there's alpha. Those are the, what's that? No, not offhand. There's alpha. And these are the ones that you would use for using measurements. And then there's beta. All right, so theta, alpha, beta, those are the typical ones you're going to use when you're working with measurements. All right, so we have, I'm going to reduce this. 5/10 is 1/2, right? Okay, I'm going to find the cosine. Let me write it up here. Cosine of theta equals 1/2. Take a look on your calculators, and you're going to see something that says this. Cosine to the -1. This is what we're going to use to be able to figure out what that angle is. And here's how this works. Here's how this works. The cosine to the -1 is the inverse, or the opposite. I shouldn't say inverse, because that's inverse. It's the opposite of cosine. So if I do cosine of -1 to a cosine of theta, this just equals theta. These cancel each other out. All right? So whatever I do to one side, I have to do to the other. 1/2. This ain't going to work, is it? All right. Let me redraw this. Cosine -1 to cosine of theta equals cosine -1 of 1/2. These cosines cancel out, and you end up with theta equals cosine -1 1/2. Do that on your calculator. Take the inverse cosine of 1/2. What do you come up with? $60. That's interesting. You got her. 60 degrees. Theta equals 60 degrees. I want to show you something. What kind of triangle did I create? 1, 2, square root of 3. X, 2x, x square root of 3. X is 5, 2 times x is 10. 30, 60, 90. And we just proved that it's a 30, 60, 90. Oh, sure. If you would have noticed that this was, and this is something you do on ACTs, because this may be something they give you, just like this. You may have a 5 and a 10 here, and you have to go through this to figure it out. When you can look at this and say, hey, this is half of that, and I know a 30, 60, 90 is 1, 2, square root of 3. I know that that's a 60-degree angle. Okay? Do you see how we use the inverse of the trig functions now? Let's take a look. What do we have to know? We have to take one of the angles, right? We don't know which angle it is. Can I figure out what both angles are? Can I figure out what both angles are? Sure. I can figure out what both angles are. They're looking for just M, but if I get M, I subtract it from 90 and I got the other angle, correct? What sides am I using here? If M is here, if we're using M, no, a hypotenuse. Well, yeah, this is the hypotenuse. I was thinking at first this was. Opposite 90 is hypotenuse, so I'm using my adjacent and my hypotenuse, so I know it's cosine of theta equals 4 over 14. And I figure it out. Okay? Yep, inverse cosine. All right? You've got 11 problems. I've started some for you.